Hello everybody, Harry from GMAT Ninja here, and welcome back to our series of quant videos for the GRE. Today's video is all about coordinate geometry, and to go into a bit more detail, be a bit more specific, in this video I'm going to have questions that are going to cover all of this. So we're going to take a look at horizontal and vertical lines, and then drill down into coordinates and how to find the midpoint between two coordinates. I'll give you a couple of different ways of looking at that, or how to find the distance between 2 points. Then as we move on from coordinates to just looking at full lines, we'll take a look at how to find the slope of a line, or how to find the intercept, whether that is the x-intercept or the y-intercept. Then we'll get into how all that ties together into this equation of a line, this y equals mx plus b format that you've probably seen if you've taken a look at a few GRE coordinate geometry questions. Then we'll take a look at how the GRE could ask you about parallel and perpendicular lines, and we'll get into a couple of problem-solving questions in GRE coordinate geometry. In other words, how could the GRE twist and turn the content to make this stuff a little bit more difficult? Now, talking about the difficulty level of this video, I don't expect things to be too difficult. If you're aiming for anything up to a 160, then yeah, stick around for at least the first part of the video. Anything up to these problem-solving questions towards the end, we're going to have a bunch of content in there that you're going to need to be able to answer coordinate geometry questions. If you're aiming for something over a 160, then I'm hoping that those first few questions aren't going to be too challenging, but maybe we'll have a little bit at the end that will trip you up maybe. If you're aiming for something over a 165, then this video is probably not for you unless coordinate geometry is a topic you really struggle with. Yeah, maybe we've got something right at the end that might pose a bit of a challenge, but I doubt it. This video is not designed to be that difficult. It's really all about the content. So the way that we're going to make this work is I've got 8 questions lined up. I'll put them up on the screen, give you a couple of minutes to take a look at it. Then I'll take the question away. I'll have it on the board behind me, and we can work through the solution and take a look at any content we need as we discuss the problem. All right, so I'll get the first question up on the screen for you now. Given this is a GRE, I'll give you about 1:45 to take a look at this before I take it away. I'll get it up and give you a chance to take a look at it. All right, so best of luck, everybody, and I'll see you back here to take a look at the solution once you've had a chance to have a go at this one. Okay, if you'd like a little more time to take a look at this question, now's your chance to pause the video. But for now, I'm going to take this question away so that we can take a look at the solution together. All right, there's a bunch of different things to talk about in this video that I'm going to put to one side for a second. I'm not ignoring them. We're going to come back to them. But the bit that I want to focus on to begin with is that we've got a straight line, and this line does not cross the x-axis. And so I want to think about conceptually, what does that mean before I try and layer the algebra on top of it. So to begin with, let's just draw a line on here. Now this line clearly crosses the x-axis there. So I want to think about what does it mean for this line not to cross the x-axis. Now I could think about drawing a second line. Maybe I'll draw it, it'll be a bit more flat. And then on my set of axes here, well, this line doesn't cross the axis, the x-axis on this set of axes. But the thing with coordinate geometry is you've got to think about this as some sort of infinite idealized space. This x-axis could go off the side of the board, it's going to go off the side of the screen, it's just going to keep going. And this blue line that I've drawn here is going to keep going up and up and up. It might go up slowly, but eventually it's going to cross the x-axis, probably somewhere way off to the side of the screen over there, but it's going to cross the x-axis. So if I want to draw a line that will never cross the x-axis, it's going to have to, and I've never been very good at drawing, so I'm hoping that comes out okay on the screen. The point is here that this line, if it's never going to cross the x-axis, it must be straight and must be parallel to that x-axis. And so that straight line can go on and on forever, but it's never going to tilt down, it's never going to tilt up, it's going to be flat, it's going to be horizontal the whole way, forever and ever, no matter how far across the board you go, either this way or that way. We've got a horizontal line, that's never going to cross the x-axis. Now, what we can say about this line, I'm going to pick a number. I'm just going to say that this crosses, that this point is at 5. Well, the coordinates here, let's say that's -3, 5. The coordinates here, that can be -6, 5. Over there, that could be 2, 5. There, that could be 7, 5. And we could keep going. I don't know, I'll stick in -1, 5 there. Point is that for this line that I've arbitrarily selected, it goes through, the y coordinate of every point it goes through is 5. So if I wanted an equation of this line, if I wanted a way of describing this line, I could just say y = 5. Now, to bring this back into the question, we are told that this straight line that I've just drawn has an equation y = mx plus b. Now, the 5 that we've got there, that's the point where this line crosses the y-axis, and we're going to get into slopes and intercepts and how to find them a little bit later. But the point here is this equation. It looks a little bit like this y = mx plus b if I had as the m was 0. So it's y = 0x plus 5. Now, like I said at the start, I chose that line completely arbitrarily. It could have been going through 2. And then that would have been -3, 2, that would have been -6, 2, so on and so on and so on. And this line would be y = 2. But the equation of this line, the full equation of this line, would be y = 0x plus 2. And that was 0x plus 5. So I don't know where this horizontal line is. It could have been this red one going through 5. It could have been going through 2. It could go through -3. It could go through -7. I don't know how high up or down it is, but the one thing I do know is that if this line is not going to cross the x-axis, then the slope of this line is going to be 0. So to bring this into the question, quantity A is the product of m, and that shouldn't be a capital B, that should be a lowercase b. The product of m and b. I don't know what b is. B could be anything. As I said, I don't know how high up or down this slope is, but m, definitely m = 0. So the product of m, which is 0, and b, whatever b is, could be 0, could be 1, could be 7, could be a half, could be anything. But the product of 0 and b, well, that's going to be 0. Now, so quantity A is 0, quantity B is 0. The way quantitative comparison questions work, because both of these are the same, the correct answer for this. So like I said, later in this video, we're going to get into how to find the slope, how to find the intercept. So if that bit was a bit of a mystery to you, don't worry. We're going to get into more detail about that later. The bit that I'd like you to take away from here is if a line is not going to cross the x-axis, it's got to be a horizontal line, and a horizontal line by definition has a slope of 0. Now, when you're writing out in full, you don't need to write that 0x bit. The equation of a horizontal line is just y = 2 or y = 5, or really for a horizontal line, the equation of that's going to be y = 2, some number, and that's going to be the y-intercept as well. And that number will give you the value of every y coordinate that line goes through. Right, so if that's a horizontal line, the other one that we might need to worry about is a vertical line. And so if I do something similar and draw the equation of a vertical line, then if this x point is going to be 1, then the coordinates here would be 1, 2, 1, 5, 1, 7, 1, -3. So what I hope you can see here is if I draw a vertical line, it's the x coordinate that remains consistent throughout. And so the equation of a vertical line in this case would be x equals 1. But to generalize, we could just say the equation of a vertical line is going to be x is equal to some number. I don't necessarily know what the number will be. The general equation for a vertical line will just be x equals some number. In this case, it was x equals 1. So the equation of a horizontal line is y is equal to a number. The equation of a vertical line is x is equal to a number. And that's really all I need you to know in order to get through this question, because the product of m and b, the slope of our horizontal line was 0, which meant quantity A was 0, which meant that A and B were the same. And so we could choose C here. All right, so horizontal and vertical lines, that's how they're going to work. Next question. This question that we're going to put up in a second is not particularly GRE-like. It resembles a GRE question, but there's a bit too much going on. So I'm going to give you a bit more time to take a look at this problem. We'll break it down, go step by step, and get to a solution in a couple of minutes once you've had a chance to look at it. Okay, like I said when I put this question up, that this is a bit longer than your typical GRE question. So if you need a bit more time, now's your chance to pause the video. You can always come back to the solution in a little bit. But for now, I'm going to take this away so that we can go through this solution together. All right, so there's a couple of things going on here in this question. There's going to be a midpoint, and we're going to find the distance between 2 points. So I'm going to break this down, split those two processes up so that we can look at them individually. If we take a look at the question, again, another quantitative comparison question. Quantity B, again, is just a number, so I don't have to do anything with that. I don't have to worry about that until right at the end. Quantity A is the one that we're going to be working with. So quantity A says we're looking for the distance between 0, 7 and the midpoint of -2, 2, and 8, 6. So in order to find the distance between 0, 7 and this midpoint, the first thing I need to do is find this midpoint. So that's the bit that I'm going to focus on first. And I've got -2, 2 and 8, 6 drawn up here on this set of axes so that we can work over here. Now, there's two ways that I would go about finding the midpoint between two coordinates. Which one you choose, it depends on the question. Sometimes the first one's going to be very helpful. Sometimes the second one's going to be very helpful. There are times when the first one is the only one that'll be able to do the question. There are times when the second one's the only one to be able to do a question. So I'm going to show you both, and I take a look. And if you get a question, that's when the experience comes in of when you're going to know which method to use. Now, the first method's a bit more algebraic. I don't need the diagram, but if I'm finding the midpoint, and we'll call this method 1, And what I'm going to do there is I'm going to take the average of the x coordinates of these 2 points and the average of the y coordinates of these 2 points. The average of the x coordinates of the 2 points will be the x coordinate of the midpoint. The average of the y coordinates of the 2 points will be the y coordinate of the midpoint. So what I can say is the midpoint is going to be, for the x coordinates, I take -2 and I'm going to add 8. And to find the average, I'd divide that by 2. For the y coordinates, the y coordinate was 2 and 6, so 2 plus 6, and I divide that by 2. If I put these in a set of parentheses, if I just simplify this down, this is going to give us the coordinates of the midpoint. So -2 plus 8 is 6, 2 plus 6 is 8. 6 divided by 2 will give us 3, 8 divided by 2 will give us 4, and so the midpoint between these two is going to be at 3, 4. So that's your method 1, and we can use this method in this question to find that one. The other way of doing this is a bit more visual. So if I take this diagram, I've got point 1 here at -2, 2, point 2 there at 8, 6. And what I'm going to do is put a triangle. This line's going to run along the parallel to the x-axis, and this line will run parallel to the y-axis. And so because the x and y coordinates are at right angles to each other, I know that I've got a right angle triangle here. Now what I can do is fill in the lengths here, again, because they line up with the coordinates. If the x coordinate here is -2 and the x coordinate there is 8, then the distance from -2 all the way up to 8, the length of that line is going to be 10. Doing something very similar vertically, if I'm starting at 2 and going all the way up to 6, then the length of that line is going to be 4. So what I can say is, to get from this first point to the second point, I would move 10 to the right and 4 up. Now to get to the midpoint, I want to do half that journey. So I can draw another of these triangles in. I'll use a different color here. And I want to go halfway. Well, halfway, if this length of this line is 10, then half of that is going to be 5. And if the vertical line here was 4, then half of that will be 2. And so the journey I need to go on, if I was going to go the full way, I would go 10 to the right and 4 up. But to get to the midpoint, I would just go 5 to the right and 2 up. So starting at -2, 2, I'll do the x-coordinate first. So -2, I go 5 to the right, I'm going to end up at 3. And in the y-coordinate, I'm starting at 2, and I'm going to go 2 up. That would give me 4, and thankfully, both of our answers match. And so sometimes you'll get given the coordinates with a bit of algebra in, and this averaging method is the only way that works. Other times, if they don't ask for the midpoint, if they say something like, find the point that is on the line between the first and the second point, but is twice as far from the first point as it is from the second, well, then this averaging is not going to work, because this finds the midpoint, it doesn't find anything else. But if I wanted to find something that's twice as far from the first point as it is from the second, I'm going to find something that's 2/3 of the way along. So rather than doing half the journey, in that case, I could use this other method and go 2/3 of the way along. So this method's a bit more flexible. This is a bit more rigid, but like I say, if the coordinates are given to you with a bit of algebra in it, then this is the only way that possibly the only way that you're going to be able to do it. So 2 methods of finding the midpoint. They can both work in certain questions, but sometimes there's one method that works better. Sometimes there's only one method that works. Have a play around with them. Hopefully they both help you there. All right, so at this point, we've got the midpoint of these two. So what I need to do is find the distance between 0, 7 and 3, 4. So I'm going to rub a few things out here so that we can simplify what's on the diagram. I'm going to leave that point 3, 4 there. That's one of our starting points. And then the point 0, 7 is going to be on the y-axis about there. And so what I've got now is, if I join those 2 points up, I want to find the distance between those points. Now again, I'm going to make use of the fact that we're in a coordinate geometry system, that the x-coordinates and the y-coordinates are perpendicular to each other. So if I draw another triangle, I've got the y-axis, I'll go horizontally out from that y-axis, that's a right angle. And now I can start looking just at each set of coordinates individually. I'll do the x-coordinate first. This starts at 0, the x-coordinate here is at 0, the x-coordinate of this point is at 3, so the length of that line is going to be 3. Vertically, this is at 7, This point's at 4, so I've got a distance of 3 there. So I've got an isosceles triangle, 3, 3 triangle, and then the distance I want to find, let's call that d. All right, so what I can do now is a bit of Pythagoras, because I've got a right angle triangle, and say d squared is going to be 3 squared plus 3 squared. So d squared is 9 plus 9. D squared is 18. And so d is going to be the square root of 18, which will come out if you can either dig the calculator out and take a look at this, or we can say that that's going to be 3 times the square root of 2. One of the things you might want to just tuck away for later, if you need an approximation, the square root of 2 is approximately 1.4. So 3 times the square root of 2 is going to be approximately 3 times 1.4, which will come out to be 4.2. 4.2 is less than 4.5. So I can say quantity B here is going to be bigger than quantity A. And so the answer to this question is going to be B. All right, so like I said, there's a lot going on there. That is more than you're going to see in a GRE question. You'd typically be asked either for the midpoint or for the distance, but I've lumped them both together in this question so that we can deal with as much content as possible in this video. So both two processes there. If you need to rewind and take another look at this explanation, go for it. We'll still be working through the rest of the problems when you get back. But like I say, two different methods for the midpoint. Sometimes either one will work. Sometimes you've got to make a decision. Play around with both so that you get comfortable with both of them. And then if you're finding the distance between any 2 points, you can draw this triangle using the y coordinates, the x coordinates. That'll give you a right angle triangle, and you can set up a Pythagoras theorem equation that'll find you the distance between the 2 points by the end. All right, we'll keep this rolling. I'll get the next question back up on the screen. Hopefully they'll start looking a bit more like traditional GRE questions. So I'm going to go back to giving you just a minute 45 to take a look at this one. And I'll see you back here to take a look at the solution soon. All right, I hope that's enough time to take a look at this one. Now's your chance to pause it if you want a bit more time, but I'm going to take that question away so that we can work through the solution here. All right, so we're moving on from coordinates into lines. And in this question, eventually, I want to find the x-intercept. That's what we've been asked for, but there's a few steps we're going to need to go through before we're going to do that. I'm going to find the slope of this line. I'm going to find the equation of this line, and then I'm going to use that equation to find the x-intercept here. So first step in that process, I want to find the slope of this line. So I've got the line drawn up here. Now, third question here, and I've drawn a diagram for all of them. You might have noticed that. I'd say with coordinate geometry, even though we weren't given a diagram in this question, I'd take the time to draw one. Even though it takes an extra 5 seconds, it's probably going to save us a chunk of time as we go through the solution. So, yeah, might look like it takes a bit of time. Draw the diagram for coordinate geometry questions. It's probably going to help you. Now, this is the basic diagram we were given in the question. I've got a line, goes through these 2 points. I know eventually it's going to cross the x-axis, and I want to find the x-coordinate there. That's my eventual goal here. What I'm going to do now is add another one of those right-angled triangles in that we've been using for the midpoint or for finding the distance between the points. And so I'm going to draw a line, horizontal line parallel to the x-axis, and a vertical line parallel to the y-axis. And because I know that these 2 lines of the triangle line up with the axes, I know this is a right angled triangle. And then next step, exactly the same as we've done so far, I'm going to find the length of this line. So in the x direction, we've got a coordinate at 3, I've got a coordinate at 9, so the length of that line is 6. Similarly, in the y direction, this point's at 13, that point's at 25, so the length of that line is 12. And so what I can do with this triangle now is to say that the slope is equal to the change in the y direction divided by the change in the x direction. So in this case, change in the y direction is 12, change in the x direction is 6. 12 divided by 6 will give me a slope of 2. Now the thing to look out for here is that if I'm moving left to right, then the x direction will always be positive. So always, if you're doing the slope, always go left to right, x direction will be positive, but then you've got to make a decision. Is this line going up or is it going down? In this case, the line's going up as I move from left to right, so the slope is going to be positive. But if I drew another line in here, in this case, if I put a couple of points on it, in this case, we will go left to right in the x direction, and that's always positive, but this time the line is going down, so this time the line would be negative. And so x direction, always go left to right. Y direction, that's where you've got to make a decision. Is the line going up, in which case it's a positive slope? Is the line going down, in which case it would be a negative slope like this line? And in that case, let's just say that this length is 6 and that length is 12, just like up here. Well, I would have to make that negative 12 because the line is going down the way, and so the slope would be negative 12 divided by 6, which would give me negative 2 there. So that's the only thing to watch out for with the slope, is just which direction is the line going. Is it going up or down? Right, so now that I've found the slope, the next bit I'm going to go and look for is what's the equation of the line. So the general equation of a line is this y equals mx plus b setup, where the y and the x represent the coordinates at one point of a line, the m is the slope, and b is the y-intercept, or where this line, the y-coordinate of where this line crosses the y-axis. Now, in this case, we found the slope, that's 2, so I can put that into this equation, y equals 2x plus b. Now, in order to find the b, in order to find the y-intercept, couple of different ways that this can happen. In this question, the way that we do it is to take one of the coordinates, doesn't matter which one, we'll get the same answer. Take one of the coordinates and put the x coordinate of that point into the x here, take the y coordinate of that point into the y there, and that'll give you an equation that will just leave you with b. You'll be able to find b. So like I said, doesn't matter which point I could use. I'm going to use 313 because the numbers are a bit smaller. Hopefully it'll be a bit nicer. So at 313, the y coordinate is 13, the x coordinate is 3, and I'll leave the b there. Go and solve this for b. So 13 is equal to 6 plus b, which will give me b equals 7. So the equation of my line is y equals 2x plus 7. Now that's the general equation of this line. I can basically do anything now. I can tell you anything about this line from this equation. The bit that we want is where's this point, the x-intercept. So in order to find the x-intercept, what we can say is at the x-intercept, give myself a bit of space to do this, at the x-intercept, the one thing we definitely know is that y equals 0. So when you're trying to find the x-intercept, you can take the equation and set the y equals 0 in there, solve it for x, and that'll tell you what the x-intercept is. If you want to find the y-intercept and you only have the equation, you can do the reverse. So at the y-intercept, the x value will be 0. At the x-intercept, the y value will be 0. So what we can say is we've got our equation here. If I put y equals 0 into this equation, I'll have 0 is equal to 2x plus 7. So 2x is equal to -7, and x is equal to -7 over 2, which is -3.5, which means the coordinates of our x-intercept are -3.50, or in other words, answering this question, the correct answer here is going to be C. All right, so bunch of steps there. Like I said, we found the slope first. We used the slope and one of the coordinates. Doesn't matter which one. We could have done it with the other one, but we used the slope and one of the coordinates to find the equation of the line. And then once we had the equation of the line, we said at the x-intercept, y was equal to 0. Now, there are other ways in which you could do this question. So you could take the slope is 2. So we could say that for every 1 unit you go to the left, I'm going to go 2 down. And so that would be 211. And we could keep going. And there'd be a point at 1,9. And you could just keep working your way down and working your way down. And eventually you'd be able to get to that x-intercept. There are other ways of doing it. I wanted to show you each different step so that you could see them, so that we can sort of take these different bits and plug them into different questions. Because sometimes I'm going to want to find the slope. Sometimes I'm going to be given the slope and I want and a coordinate, and I want to find the equation of it. You can take each of these 3 bits and use them in different questions, which is why I wanted to go through the full process here. All right. So we've found the midpoint, we've found the distance between 2 points, I've got the slope, I've got the equation of a line, and I can find intercepts from that equation. I'm going to start using this all together in different questions. So I'll get the next one up on the screen, give you a couple of minutes to take a look at it, and I'll see you back here soon. All right, pause here if you want a bit more time to take a look at this one, but I'm going to take that question away so that we can work through this one together. All right, the first thing I would notice if I open this question up is there's a lot of text. There's a lot of going on here. So please don't be intimidated. Don't rush the reading. Take your time. Let's read this carefully. Let's make sure we can get through this in a reasonable amount of time. So what's going on here is we were given a figure, and this figure shows the line P with equation y equals ax plus b, and the line Q with equation y equals cx plus d. So we've got a figure, we've got 2 lines here. Which of the following could be the equations of P and Q respectively? So in each of these answer choices, this first line, that could be the equation of line P, and this could be the equation of line Q. And I've got to work down through each of these answer choices and say, well, which one looks reasonable? Which ones could be these 2 equations? So a couple of things I would notice about this diagram. First of all, the slopes are different. So in this case, the slope of P is steeper than the slope of Q. And so what I could say about this is that A, the slope of line P, must be bigger than C, which is the slope of line Q. There's one way we're going to make some decisions here. The other way is to say that, well, the y-intercept of line P is bigger, is higher up the y-axis than the y-intercept of line Q. And so while A is bigger than C, that's the slope, I can also say B is going to be bigger than D. The y-intercept of line P must be bigger than the y-intercept of line Q. So what I'm going to do, I'm going to take that second one first. I'm going to take the intercept thing first. And so what I should be able to do is look at each line, and the y-intercept of line P, which is the B value, should be bigger than the y-intercept of line Q, which is the D value. So in this first line in answer choice A, the y-intercept of line P is 5, the y-intercept of line Q is 7. In this case, D is bigger than B. I want B to be bigger than D, and so answer choice A is not going to be one of our answers. We can cross that one out. We could have looked at the slopes, but I'm going to deal with the intercepts first. All right, working my way down, and now I can just go through each answer choice checking the same thing. Answer choice B, 6 is bigger than 4, so I can leave B alone. In C, I've got 2 here, 13 over 4. So if we turn that into a decimal, that's 3 and a bit. It's more than 2. So I can cross C out, because again, the y-intercept of line Q would be bigger than P if Q was right. Looking at D, 9 over 2, that's 4.5, and 16 over 5, that's 3.2. So yeah, 4.5 bigger than 3.2, so I can leave D in for now. In E, 3/5 and 5/6. Again, if you need to, we could check those out. 3/5 is going to be 0.6, 5/6 is about 0.8. So again, the y-intercept of Q is bigger than P in answer choice E. I want it the other way around, so E is not going to be our answer. And for F, I've got 3 here and 5 there, so I can cross F out. So dealing with the y-intercept alone, I've been able to cross out A, C, E, and F. You could have dealt with the slopes first as well, and let's take a look at one of them. That would have also gotten rid of C, because in this case, the slope of C, that's about 1 1/3, and the slope over here, that's 2 1/4. So the slope of what potential line Q in answer choice C is bigger than the slope of potential line P. And we want it to be the other way around. We want the slope of P to be bigger than Q. So dealing with the slopes, you could cross C out. It doesn't matter the order you do, intercept first or slope first, you're going to get to the same answer eventually. So I've crossed out A, C, E, and F. I need to check the slopes of B and D. I need the slope in this line to be bigger than the slope in that line. Well, in B, it's looking good. I've got a 2 here, I've got a 1 there. So in B, the slope of line P is bigger than the slope of line Q. The y-intercept of line P is bigger than the y-intercept of line Q. I want both those things. B's looking good. On to the next one. In D, I've got 5 over 2 here, so what's that? 2.5, and 5 over 3 there, that's about 1.66. The slope of line P is bigger than the slope of line Q. As we said last time, the y-intercept of line P is bigger than the y-intercept of line Q, so D is looking good as well. And so the answer to this question is going to be B, and it's going to be D. We've got 2 correct answers here. All right, so like I said, doesn't matter which order you take them in, either the slope first or the intercept. As we did here, we'd looked at the intercept first, that crossed a load of things out, and that meant I just had to check the slopes. The bit to do is when you got this question in the setup is to say, well, what can I tell? What is different about these two slopes? What is different about these two lines? I can deal with the slopes, I can deal with the intercepts, and that gave us enough information to get through what looks like a really horrible question in not too great an amount of time. All right, I'll get this one out the way. We'll get the next question up on the screen. Okay, a couple of minutes to take a look at this, and I'll see you back here soon. All right, now's the chance to pause it if you want some more time to take a look at this one, but I'll take this question away so that we can work through this one together. All right, so this is the question where we get into parallel and perpendicular lines. In this question, we're talking about perpendicular lines, but I'm going to throw parallel lines in there as a bit of an aside so that we covered everything. All right, so the bit that we know is our line is perpendicular to this. We were given this y equals 3x plus 4. Now, what I can say, I'm going to do parallel lines first so that we can do the whole question together. But in parallel lines, what we can say about them is they have the same slope. So the slope of this line is 3. If I wanted to write the equation of a line parallel to this, I could instantly say it's going to be y equals 3x plus b. I might not know what that plus b is. I might have to do a bit more work to find it. But what I can say is if I know that something I want, a line that I want is parallel to this one, they're going to have the same slopes. My new line's going to have a slope of 3. Now this question's talking about perpendicular lines. And what you can say about perpendicular lines is that the product of their slopes is equal to -1. Or to put that into some sort of equation, if I have the slope of the first line and I multiply it by the slope of the second line, that will equal -1. So in this case, I've been given a slope that's 3, and I want to find the equation of this line r. So first step, I need to find the slope of this line r. Well, if I call this equation 1, and I call r equation 2, then using this, I can say the slope of line 1 is going to be 3. So m1 times m2 is going to equal -1. The slope of line 1 is 3. I don't know what the slope of 2 is. That's the bit I want to find. And because they are perpendicular, because I know they're perpendicular, that's going to equal -1. So from that, I can rearrange to find m2. That's -1 over 3. And so I know the slope of my line r is -1 over 3. So I can write out the beginnings of my equation of this line because I know the slope. Don't know what the intercept is. We're going to go find that in a minute, but I know the slope. So perpendicular lines, if you multiply the slopes together, you should get -1 if the lines are perpendicular. And if you know they're perpendicular, you can use this formula to find the slope of one line if you know the slope of the other. All right, so I've got the beginnings of my equation. I just need to find out what this intercept is. I'm told this line goes through the point 9, 4. And so my y-coordinate of that point is 4, and that equals -1/3 times by the x-coordinate, which is 9, plus b. Now I can expand this set of parentheses. So 4, -1/3 times 9 will give me -3 plus b. So 7 equals b, and I know the equation of my line is y is equal to -1/3 times x plus 7. All right, so I can take that over to the answer choices and say, well, the slope of my line is -1/3. And over here, I can instantly see, well, A, B, and C all have slopes of 3. Y equals 3x, y equals 3x. And if I expanded this set of parentheses, that would be y equals 3x. So it's going to be one of D or E. Now, there's two ways of looking at this point. I could either take these two and rearrange them into some sort of y equals mx plus b format, or I can take the equation that I've got, and if I multiply everything here by 3, I'll get 3y is equal to -x plus 21, and then take the x to the other side. 3y plus x is equal to 21. And now it is still the equation of a line. It's just not in that traditional y equals mx plus b format. I've just rearranged things a little bit. Now this is identical to D. And so D is going to be the answer to this one. And I could take D, 3y plus x equals 21. I could take x to the other side, -x plus 21, and divide everything by 3, and I'm back to that y equals mx plus b format. So just because it's not in that traditional y equals mx plus b format doesn't mean the answer's wrong. It just means you might have to do a little bit more work at the end of the question to get where you want to go. All right, so that's the end of the sort of the content part of this video. We've taken a look at midpoints, distance between points, finding slopes, finding intercepts, finding equations on lines, now parallel and perpendicular lines. What I'm going to do now is start to twist and turn the content and look at the different ways the GRE could ask you. So if you're aiming for anything up to a 160 and you've understood everything we're doing so far, fantastic. You don't need what's coming next. If you're aiming for something over a 160 or you want to challenge yourself for a little bit, stick around. Hopefully we'll have something that you find a bit difficult. I'll get the next question up on the screen. See you back here in a couple of minutes' time. All right, pause here if you want some more time to take a look at this question. I'm going to take it away so that we can take a closer look at this one together. All right, so like I said before we put this one up, we've got to the end of the sort of the content bit of this video, and now we're into using all those bits of content and getting to some problem solving here. So in this question, we're going to find the area of a triangle. Now, yeah, there was no diagram in the question. I don't know where this triangle is, and the first part of this is finding out where is the triangle that we are going to find the area of. So if I start by saying I'm going to do the diagramming for this first line, the y equals 3x minus 9 in red, and for the y equals negative 4x plus 26 in blue. First thing I'm going to need to do is draw both these lines. Now, in order to draw a straight line, basically all I need is 2 points on that line, and then I can join them up and just keep that straight line going. Now, the easiest points that I might be able to find for these two are the x-intercept and the y-intercept. So if I deal with this red line first, so we've got y equals 3x minus 9. So at the y-intercept, the x-coordinate equals 0. So I can plug x equals 0 into this, and that will give me negative 9. Alternatively, I can just take that number off at the end of the equation here. So I know that this line goes through, x is 0, y is negative 9 down here. Now, for the x-intercept, the y value is 0. And so I can do a very similar thing here. Set the y-intercept equal to 0. That gives me 3x minus 9. So 3x equals 9, and that will give me x equals 3. So I've got a point here, negative 9. I've got a point here at 3. I know that this line goes through these 2 points, so I can join them up, keep that line going, and there's my first straight line. All right, I won't go through the whole process with the other line, but we can do, and we can say that the y-intercept of this point is going to be up at 26, and the x-intercept of this line is going to be about 6.5. And so I'm going to take this line, join those 2 points up, and here is the triangle. We've got a triangle formed from the x-axis, from the first line, from the second line. I want to find the area of that triangle. Now, finding the x-intercepts was not a total waste of time here, because that will give us the length of one of these sides of the triangle. This point goes from 3 to 6.5, and so the length of that line there is going to be 3.5. Now, various ways of finding the area of a triangle. I can consider this to be the length of the base, which means that the height would be the perpendicular distance from the x-axis to the point where the red line and the blue line cross. Now, fortunately for me, again, because we're in coordinate geometry, that height there is the same as the y-coordinate of this point. And so that's what I need to find in order to finish this problem off. So I've got this first line, y equals 3x minus 9, second line, y equals minus 4x plus 26, and if I can find the y-coordinate of where those 2 points cross, that'll give me the height of my triangle. I can put that together with a 3.5, and there's, that'll give me enough to find my answer. Now, what we can say is that the point where 2 lines cross, this point here, is the same as solving the 2 equations you've been given as if they were simultaneous equations. So I can take this first equation, y equals 3x minus 9, and the second equation, y equals negative 4x plus 26, and solve them as if they were simultaneous equations, and that'll give me the answer. Now, I know I want the y-coordinate, but just given how these are written out, it's going to be easier for me to find the x-coordinate first, because I've got a y equals something and a y equals something. So at this point, where the y-coordinates are equal on both lines, I can just set the right-hand side of these equations equal to each other. And this will give me something I can use to go and find x with. So rearranging this, 3x minus 9 is negative 4x plus 26. Take all the x's over to one side, 7x, take the numbers to the other, equals 35. And that gives me x equals 5. I can then take this and put it back into either of the equations. That'll find me the y-coordinate. I'll use this first one. So in y equals 3x minus 9 at x equals 5, I get y is 3 times 5 minus 9. 15 minus 9 will give me 6. So the coordinates of where these 2 lines cross are going to be 5, 6. All right, I don't necessarily need the 5. It was just something I found on the way to getting the 6, which is what I really wanted, because that gives me the base of my triangle is going to be 3.5. The height of my triangle is the y-coordinate, that's going to be 6. So the area that I wanted all the way at the start is a half times the base times the height. So a half times 3.5 times 6. That's going to be 21 divided by 2, or 10.5. And so the answer to this question is going to be B. So yeah, a lot in there. That's why at the start of this question, I'd be really thinking, what is the path that I want to follow here? I need to know where that triangle is. By finding the x-coordinates, the x-intercepts of both of them, that gave me the base. So now that I found one of the things that I want, that gave me a hint that, okay, if I just find the coordinates of where these 2 lines cross, that'll give me the y value for that. That would be the height of the triangle. Now I've got the base, now I've got the height, I can multiply those together and that'll give me the answer. So yeah, a lot going on here. And if you can see that path from the start of the question, that'll mean that you can get through this efficiently, which is what you're going to need to do this question the time you've got available on the GRE. All right, that was heavy on the algebra. Next question I've got for you is going to be far more conceptual. There's going to be far less algebraic work doing. It's still on the more difficult side of what we could see on coordinate geometry. So I'll get this one up on the screen, give you a couple of minutes to take a look at it, and I'll see you back here to go through the solutions soon. Okay, not too much algebra to do on this one, so I hope that's been enough time. Pause here if you want some more time to think about it, but I'll take that question away and we can look at the same diagram here on the board. All right, so this question, quantitative comparison question again. We're back to one of those, and which is bigger, A plus C or B plus D, where A, B, C, and D are some of the coordinates of the points we've been given there. This is one of those questions where I would ignore that for the beginning though, and let's focus on the diagram and what we can learn from it. So yeah, I've got these 2 points here. Again, put those to one side for a second. The bit that I want to focus on is the line that we've been given. I know it goes through this point 8, 8. I also know it goes through the origin, so it goes through the point 0, 0. Which means that from 0, 0 to 8, 8, straight line, I know here that the slope is 1. For every 8 units it goes right, it goes 8 units up. The slope here is 1. So what I can say is that on this line, the x-coordinate and the y-coordinate are the same. Now we can look at what happens if we move off that line and go either side. So AB is to the left of that line. So if I know that the coordinates here, let's use this x, y one, if the x is equal to the y, if I go left along that line, the y coordinate is going to stay the same, and the x coordinate is going to get smaller because I'm going closer and closer to the y-axis, I'm moving left. So if x equals y, if the x coordinate equals the y coordinate when you're on the line, if I move to the left of the line, the y coordinate's the same, the x coordinate's getting smaller, so the x coordinate is going to be less than the y coordinate if I move that way along the line. So this point here, AB, is to the left of the line, and so we can say that A will be smaller than B. All right, we can do a similar thing down here. If we're on the line there, again, I've got the points x, y down here. On the line, x equals y. Well, now, again, if I move to the left of the line, then the y coordinate is staying the same, and the x coordinate is getting more and more and more and more negative. In other words, over here to the left of the line, if I picked a point there, the x coordinate again is going to be less than y. It's the same as up there. If I move left off that line, the x coordinate is going to be less than the y coordinate, and so C is going to be less than D. And so from that, we can say, look, A is less than B and C is less than D. So if I compare the first half of these two, A and B, on this side, quantity A is smaller because A is less than B. And then if I can compare the C and the D, well, C is smaller than D. So over here, I've got two things. I'm adding them together. B is bigger than A, D is bigger than C, so B plus D is going to be bigger than A plus C, and overall I'm going to get the answer of B there. All right, so in this question it was just, I used the clue of where the line was, and I know that because this line goes through 8, 8 and through the origin, on every point on that line the x-coordinate is equal to the y-coordinate wherever you pick a point. And then it was just a case of what changes if I move off the line. In both cases here, I've taken a look at, well, what happens if I go horizontally? But we could take a quick look and say, well, if I pick this point there, x is equal to y on that point, well, what happens if I go up the way? Well, if I go vertically up, then the x coordinate's staying the same, but the y coordinate's getting bigger. And so up here, the x coordinate again will be less than the y coordinate, which is what we would expect because we're on sort of up and left hand side of the line. If I picked a point x equals y there and went down, went the other side of the line, well, again, the x coordinate staying the same and the y coordinate's getting the smaller. So if they started out the same, the x coordinate remains the same, the y coordinates get smaller. Over here, the x coordinate will be bigger than the y coordinate. So it doesn't matter whether you do horizontally or vertically, and doesn't matter whether you go to sort of this side of the line or that side of the line, the process there is the same. You can figure out some relation between the coordinates on that side of the line, and that's enough to get through this problem. As I said, very little algebra in this one. We didn't actually do any calculations. It's just sort of figuring out what happens as you move around the coordinate grid. All right, I've got one more question for you. Hopefully this one will be a bit of a challenge. Like I say, if you're aiming for anything up to a 160, and this next question is a bit of a mystery, you're still going to be okay. This is up there as one of the hardest things the GRE could do with coordinate geometry. So I'll get this up on the screen, give you another couple of minutes to take a look at it, and we'll see you back here soon. Okay, for the final time today, if you need a bit more time to take a look at this question, now's your chance to pause it, but I will take this away so that we can take a look at this one together. All right, so like I said before we put this question up, this is about as difficult as the GRE can make coordinate geometry. So if you're aiming for anything up to about a 160, if you looked at this question and just went, I don't know what's going on here, that's okay. Yeah, this is for generally for those people that are on the other side of the 160 barrier. If you're aiming for over 165, I hope this one's okay. So really, I'm hoping to challenge the people in that 160 to 165 region. So what we've got going on here is there's some line M. I don't know much about it other than I know it definitely does not go through the origin. And what we're looking to do here is to look at each of these statements individually by itself and say, does that statement by itself provide sufficient information to determine whether the y-intercept of line M is positive? So I'm going to take the fact I know that this line does not go through the origin and then look at each of these one by one and say, right, is that enough? Can I tell from this whether the y-intercept of this line is positive? And so A tells me line N, which is parallel to line M, has a y-intercept of -4. All right, if you remember back a couple of questions ago, I said that, right, two parallel lines have the same slope. We can't necessarily compare their y-intercepts. I know that they have the same slope, but I don't know what from the question, I don't know what the slope of line M is. I still don't know what the slope of line N is. And okay, they've told me it's got a y-intercept of -4, but I can't translate that across to any information about line M. I know that line M is parallel to line N, but I don't know the slope of line N, so I don't know the slope of line M. I don't know the intercept of line M. I don't know the slope of line M. I still don't know anything about line M other than it does not go through the origin. So because I can't tell whether this line, the y-intercept of line M is positive, answer choice A has not given me enough information to determine that. A is not going to be the answer there. All right. B tells me that line M is perpendicular to this line. Y is -1/3 x plus 2 and crosses this line at -1/3. So I've got some information about the slope. I know it's perpendicular to this. And I've got some more information that line M goes through this point. Now, if you can think this through, that means that I'm going to be able to find the slope of line M. Because I've got the slope and a point on the line, I'm going to be able to find the equation of line M. And because I've got the equation, I'm going to be able to find the y-intercept. So if you know coordinate geometry well enough to be able to think through that process, then answer choice B is looking pretty good. But let's just go and figure this all out just to prove that's the case. So I know that line M is perpendicular to this one. Now, like we said a couple of questions ago, when two lines are perpendicular, the product of their slope equals -1. So this is the slope I know. So -1/3 times by the other slope, the slope of line M, the slope I want, is going to equal -1. If I divide both sides here by -1/3, I'm going to get the slope is equal to 3. So the slope that I want, the slope of line M, is going to be 3. And I know that this line goes through -1/3. So like we've done a couple of times in this video now, I can say that because I know the slope, the equation of my line is going to be y equals 3x plus b. And then at the point at -1, 3, my y coordinate is going to be 3. My x coordinate is going to be -1, and I've got a plus b on the end. 3 times the -1 is going to give me -3. Add 3 to both sides. I'm going to get my b equals 6. So y is 3x plus 6. That's the bit that I'm interested in. The y-intercept of line M is plus 6. It is positive. So the information I was given in answer choice B was sufficient to find whether or not the y-intercept of this line is positive. And so B is one of the answer choices I would take with me. All right, so I said we've just confirmed that. But like I said before we went into that process, if you can think through that process and say, well, I've got enough information to find the slope. And because I've got the slope and a point, well, that would find the intercept, or that would find the equation of the line. And because I've got the equation, I've got the intercept. If you can think through that, you wouldn't need to go through all this process. But if you wanted to confirm it, that's how we would do it. And if you can get through the algebra efficiently, we can still answer this question within a reasonable amount of time. All right, so A's out, B's in. We've got one more. This time, the product of the slope of line M and its x-intercept is negative. Now, on the face of it, that might not appear sufficient, but let's go and take a bit of a closer look at this. If I just give the general equation of line M, y equals mx plus b, the general equation of any line that we've been working with. And I know the product of the slope and its x-intercept is negative. Okay, well, I've got the slope, that's m, but let's go find an algebraic expression for the x-intercept so that I can find the product and make it negative and see if I can tell anything from that. So as we've done before, at the x-intercept, I know that y is going to be 0. So 0 is equal to mx plus b. Mx is equal to negative b. And so the x value is negative b over m. So I found an algebraic value for the x-intercept here. So now I can take the product of the slope, which is m, and the x-intercept, which is negative b over m. So the product is going to be m times negative b over m, and that's going to be negative. That's going to be less than 0. Right, well, algebraically, the m's will cross out, and I've got negative b is less than 0. Adding b to both sides of this would say that the value of b is going to be greater than 0, but go back to our initial equation that we started with. Well, b is greater than 0. B represents the y-intercept here. So while I've got no numbers, while I don't know where the y-intercept is, this answer choice C has given me enough information to be able to say B is positive. And so that answer choice C, it is sufficient to say whether the y-intercept of line M is positive. I've just gone and shown that that is the case using a bit of algebra, even though I don't know any numbers. So in this question, A is not an answer, B and C are one of the answer choices we should choose. So the answer to this question is B and C. All right, so like I've tried to make clear, that question is about as hard as you're going to see for GRE coordinate geometry. So if you were following along with that, wonderful. If you're aiming for anything up to a 160 and you weren't following along with that, totally fine. Go back a few questions, all that content stuff, finding the midpoint, finding the distance between two lines, if you can find a slope, find intercepts, and if you can use those a little bit, find parallel and perpendicular lines, that's the stuff you're going to need to be able to get up to a 160 in GRE coordinate geometry. And then these final few questions have been a bit more problem solving, and hopefully they've challenged you people that are looking for something a little bit above a 160. All right, that's all I've got for you today. I hope this has been helpful, and we look forward to seeing you back here at another one of our GRE Quant videos very soon. Thanks, everybody. Have a great day.